Many people have contacted me asking me to better describe and show how to make and use a tube spoon marker to help them bend tube. This is one of numerous tube spoon markers which anyone can make. With the help of this video and this book, Tube Bending Simplified, I hope to answer everyone's questions about tube spoon markers. Prior to hand tube bending, a tube spoon marker should be made and used to mark every bend from 1 degree to 180 degrees. This particular tube spoon marker would be used to mark perfect 45-degree bends prior to using a 15/16 inch radius hand bender. What is a tube spoon marker? One weekend while using a gauge to set the contact points on an old car, I thought a gauge could be used to mark tube to make every bend with precision. A tube spoon marker is a do-it-yourself paper marking gauge which helps transfer measurements from paper onto tube to make each bend perfectly. This tube spoon marker was made to scale in less than 1 minute with information from the Tube Bending Simplified book. It has markings on it which will help mark a tube to lay out perfect 45-degree bends prior to using a 15/16 inch radius hand bender. The 90-degree takeoff mark measurement is shown on every tube spoon marker so that anyone who ever looks at any tube spoon marker will instantly know what radius bender that tube spoon marker was made for. This two-dimensional octagon was cut to proper length, marked and bent in less than 10 minutes. By using a tube spoon marker along with an isometric sketch, the length of any piece of tube needed to complete any project can easily be calculated to within 1/16 inch, end of tube to end of tube, before the first bend is bent on the tube, regardless of the number of bends or the degree of any bend on the tube. This enlarged view of a 15/16 inch bend radius chart is from page 12 in the book. Page 12, 15/16 inch radius bender chart. Markings for any radius bender with any degree of bend can easily be transferred from the charts in this book onto paper and from paper onto a tube or a pipe prior to doing any bending. This book contains 28 charts for various size bend radiuses between 3/8 of an inch and 11 inches. The dimensions for the 7 most common degree of bends for each radius bender will be found in the charts in this book. In the bend radius chart for a 15/16 inch radius bender, where the takeoff and the 45 intersect, the intersecting number is 3/8. Likewise, where the AC and the 45 intersect, the intersecting number is 3/4. These are the two measurements which are needed to make this 45-degree tube spoon marker. 45, 3/8, 3/4. In addition, the takeoff mark measurement for a 90-degree bend is shown on every tube spoon marker. Every index card for any radius bend can be used for more than one set of bend marks, such as shown on this tube spoon marker, which includes the 90-degree bend, the 45-degree bend, and the 135-degree bend for a bend radius of 15/16 inch. Write the takeoff mark dimension, the AC mark dimension, and the tube gain dimension in a box in the center of the index card. Then mark a center line at the center point on the top edge of the index card and transfer the takeoff marks and the AC marks to the top edge of the index card. Tube gain, which is easy to calculate, is explained on page 15 in the book. Tube gain is necessary to know how much length of tube must be subtracted at each bend to arrive at the final tube length measurement which is needed for any project. Only one color fine tip magic marker needs to be used to lay out the tube spoon marks on any tube. Both the drawing on this piece of paper and the marks made on these pieces of 3/8 inch OD tube are to scale. For the demonstration purposes of this video, all initial marks will be made using a black fine tip marker. Use a 6-foot folding wood rule, and from the left end of the tube to the center of the first bend, measure 2 1/16 inches. Use your black magic marker and make a mark on the tube. Then use your tube spoon marker and line the center line of the tube spoon marker up with that black line on the tube and transfer your takeoff mark and your AC mark from the tube spoon marker onto the tube. Then from the center of your first bend, measure 4 1/8 inches and using your black magic marker, make a mark on the tube. Once again, line the center line of your tube spoon marker up with that black magic marker line on the tube and transfer your takeoff mark and your AC mark from your tube spoon marker onto the tube. After the entire tube has been initially marked with the black magic marker, remark the tube using the fat edge of a tube ferrule to make a complete circle around the tube. All takeoff marks will be remarked with a green fine tip marker. All centerline marks will be remarked with a red fine tip marker, and all AC marks will be remarked using a blue fine tip marker. Before showing you how to easily lay out a regular octagon, which is simply a circle with 8 equal length straight sides, while using a tube spoon marker, it is first necessary that you know a little about triangles. Every triangle has 3 interior angles, which together add up to 180 degrees of interior turn. In a right triangle, a triangle with one 90-degree corner, if one of the other 2 corners is a 45-degree corner, the third corner must also be a 45-degree corner. In any right triangle, the shortest side next to any angle is called the side adjacent to the angle. And naturally, the side opposite any angle is called the side opposite the angle. Both the side adjacent and the side opposite, each 45-degree angle in a right triangle, will be the same length and will be calculated by multiplying 0.707 times the length of the hypotenuse of the right triangle. The trigonometry chapter on pages 44 through 47 in the book further explains right triangles in easy to understand terms. A circle is 360 degrees in circumference. Like a circle, every regular polygon has 360 degrees of outside turn. The simplest polygon is a triangle. To calculate any bend angle for any polygon with any number of equal length sides, divide 360 degrees by the number of sides. In a triangle, 360 degrees divided by 3 sides equals 120 degrees per bend. To calculate the degree of any interior angle in any polygon, subtract the outside angle of turn from 180 degrees. 180 degrees minus your 120 degree bend leaves an interior angle of 60 degrees. 3 exterior bends times 120 degrees per bend equals 360 degrees of outside turn. I also have an example of a square. In a square, 360 degrees divided by the 4 sides of the square equals 90 degrees for each exterior bend. 180 degrees minus your 90 degree exterior bend leaves an interior bend or an inside bend of 90 degrees. 4 exterior bends times 90 degrees per bend equals 360 degrees of bend. I have one last example. This example is an octagon. An octagon has 8 sides. So 360 degrees divided by 8 equals 45 degrees per bend. 45, 45, 45, all the way through. 180 degrees minus your 45 degree bend leaves an inside angle of 135 degrees. 8 exterior bends times 45 degrees per bend equals 360 degrees of exterior bend. As previously explained, a regular octagon is simply a circle with 8 straight sides of equal length. So divide 360 degrees by 8 to find that 8 each 45 degree bends will need to be bent to bend this octagon. An octagon, both up to down and left to right, will measure 0.707x plus 1x plus 0.707x to equal a dimension of 2.414x. Where x is placed in this formula, it means times any random number. For this octagon to measure 10 inches by 10 inches on center, both wide and high, 10 will be divided by 2.414 to arrive at x. 10 divided by 2.414 equals 4.1425 or 4 1/8 inches. As such, x or each side of this octagon will measure 4 1/8 inches from center of bend to center of bend. To arrive at the length of the 0.707 side of the right triangle, 0.707 must be multiplied by 4.1425 to equal 2.928 or 2 15/16 inches. 2 15/16 inches plus 4 1/8 inches plus 2 15/16 inches equals 10 inches. Crystal clear instructions of how to make a Tubespoon marker will be found in the Tubespoon marker chapter on pages 15 through 17 in the Tube Bending Simplified book. This is an enlarged view of the Tubespoon marker, which is illustrated at the top of page 15 in that book. It shows the basic idea of how to make every Tubespoon marker. On page 6, Figure 1 explains that every Tubespoon marker starts off with a center line marking point, after which all takeoff marks for any degree of bend are measured from the center line to the left. All AC marks for any degree of bend then originate from the takeoff mark of that measurement, measuring to the right over the center line to arrive at the AC mark point on the Tubespoon marker. All takeoff marks will be to the left of the center line, and all AC marks will be to the right of the center line. If you do not find the radius chart which you need to make a Tubespoon marker in the charts, you will be able to use the two formulas on page 7 along with the tangents from the trigonometric charts on pages 45 through 47 to make any degree Tubespoon marker for any radius bender. Earlier, I said that you would easily be able to know the length of tube which is needed for any project to within 1/16 inch before bending. In this case, the 8 sides of this octagon each measure 4 1/8 inches, center of bend to center of bend. 8 times 4 1/8 inches equals 33 inches. By looking at the Tubespoon marker, we can see that the tube gain for a 45-degree bend when using a 15/16 inch radius tube bender is 0. So nothing needs to be subtracted from the total tube length for any bend to arrive at the final tube length which is needed for this project. The total length of tube which is needed for this project is 33 inches. This sketch shows that one of the 4 1/8 inch sides of this octagon will need to be bisected to be able to form this octagon into a 360-degree loop. As such, this 33-inch tube, which has been pre-marked beforehand, shows to make the first measurement 2 1/16 inches from the left end of the tube. Once you do that, make a mark at 2 1/16 inches. Then use your Tubespoon marker and line the center line of your Tubespoon marker up with that center line you just put on the tube, and transfer your takeoff mark and your AC mark from the Tubespoon marker onto the tube. Next, measure from the center of the first bend exactly 4 1/8 inches to the center of the second bend, and once again make a mark on the tube. Then again use your Tubespoon marker, lining the center line of the Tubespoon marker up with that mark you just made on the tube, and transfer your takeoff mark and your AC mark from the Tubespoon marker onto the tube. Do that with all 8 bends along the tube. Once you come to the 8th bend, you will see that from the center of the 8th bend to the end of the tube will measure exactly 2 1/16 inches. Exactly 33 inches of tube will have been measured and marked to lay out this octagon. I have another 33-inch long tube here. It has been in circle marked beforehand using a tube ferrule and 3 fine tip colored markers. Slide your tube ferrule onto the tube, and all takeoff marks will be remarked in green. Circle it all the way around the tube. Then all centerline marks will be remarked in red. Once again, circle it all the way around the tube. And then do your AC marks in blue and circle it all the way around the tube. Do that with all 8 bends on the tube. Remarks at each bend will let everyone know where to start each bend, the center of each bend, and at what point to stop bending each bend. These 2 pieces of 3/8 inch OD tube are identically marked, with 2 each 45-degree bends at 4 1/8 inches on center from one another. 4 1/8 inches, 4 1/8 inches, 45, 45, 45, and 45. One tube is straight, the other tube is pre-bent. Always lay whatever tube you are going to mark in front of you and mark your first end of tube to center of bend measurement from the left end of the tube. When bending, start with the first bend which you laid out on the tube in front of you and to your left, and line the 0 mark on the bender block up with the takeoff mark on the tube, bending over the center line, and stop your bend when the 0 mark on the bender handle lines up with the AC mark on the tube. A major benefit of using a Tubespoon marker to mark the entire tube before bending is that any bend can be bent as a right-hand bend simply by turning the tube 180 degrees in the bender, lining the AC mark up with the 0 mark on the bender block, bending over the center line mark, and stopping your bend when the 0 mark on the bender handle lines up with the takeoff mark on the tube. Right-hand bends will need to be bent whenever space limitations will not allow the tube bender to be inserted to make a left-hand bend. Before ending this video, I am going to show you how to use a Tubespoon marker to easily figure how much tube is needed when tube gain is accounted for in any bend. Refer to the 5-mark layout method shown in Figure 1 on page 6 in the book. Page 6, Figure 1. Again, we will use 3/8 inch OD tube along with a 15/16 inch radius bender, as shown in this 3-dimensional illustration. From the left end of the tube to the center line of the first bend measures 4 inches. From the center line of the first 90-degree bend to the center line of the second 90-degree bend measures 6 inches. Then from the center line of the second 90-degree bend to the end of the tube measures 4 inches. 4 inches plus 6 inches plus 4 inches equals 14 inches of measurement. 4 inches, 6 inches, 4 inches. But as shown on the Tubespoon marker, the tube gain for each 90-degree bend when using a 15/16 inch radius bender is 3/8 of an inch. There are 2 90-degree bends. So 3/8 inch plus 3/8 inch equals 3/4 of an inch. 14 inches minus 3/4 of an inch equals 13 1/4 inches of tube. As such, only 13 1/4 inches of tube is needed to mark and bend this demonstration. When marking tube before bending it, always refer to step 6 on page 19 in the book and measure from the reference mark of any bend, reference mark right here of any bend, to the center line of the next bend in succession, or to the end of the tube. This reference mark here, and you've got another reference mark here for the end of the tube. This reference mark takes into account for tube gain for that bend, regardless of whether a left-hand bend or a right-hand bend is bent. After any bend is bent, refer to step 10 on page 19 in the book and you will find that the visual center of every bend will exactly bisect the takeoff and AC marks. Takeoff, AC, visual center. Takeoff, AC, visual center. Now refer to the last sentence on page 24, and from either the takeoff mark or the AC mark on the tube to the center line of the intersecting tube run will measure the takeoff measurement of that bend. This bent tube is an exact and perfect representation of the red line shown on this 3D illustration. A more complicated bending project, comparable to this bent octagon, is explained with crystal clarity on pages 74 through 77 in the book, and can be used as a template to do any bending project. The knowledge which is contained in this tube bending book is basic information which every pipe fitter should know to be able to fit pipe or to bend tube. This book is a reference which anyone can have at their fingertips to always do a great job when bending tube or laying out pipe. If you like this video, hit the like button below, share this video with your friends, and leave a comment.